We are on nonlinear models, which is the last lesson of chapter 3, which covered exponential and logarithmic functions. So this is chapter 3, section 6 for us. So what we're going to do is talk about scatter plots, classifying them, using scatter plots and a graph utility to find models for data and choose the model that best fits a set of data. Use a graphing utility to find exponential and logarithmic models for data. Okay, so of course many real-life applications can be modeled by nonlinear equations, and we're going to look at some here in the homework. So just a reminder here about some of the graphs that we've learned about. We've definitely learned about logs and natural logs and the shape they make. They come up from infinity here and loops over to the right, and an exponential graph, and then the power function. So notice the difference between exponential and the power function. On the exponential, the exponent is x, where on the power function, the base has the letter x. So it's a matter of where the x is at. And this is one we really haven't looked at a lot, but the logistic growth model makes a funky sideways S curve. That's kind of fun. So we're going to use that regression feature today again on our calculators. And remember back from a chapter a long time ago, from chapter 1, section 7, we talked about the R value for linear equations, and the closer the R value was to the number 1, the closer it correlated to being a line. So that's on the next page here. I'll come back to this in a second. So on the next page here, just a reminder from chapter 1, we did this already, talked about the R value. So the R value, when it's positive, the slope went up. When the R value was negative, it went down. And the closer the R value was to the number 1, the absolute value of it, the closer it is to 1, the closer it was to being a perfect line, that all the points were exactly on the line. So this R value is 0.9, which was very close to being a line, all the points being on it. It's close to number 1. These points aren't terrible, but they're not all as close as the last one was. So the absolute value of this one is only 0.856. So this one had a stronger R value. And on this one, they're just pretty much scattered about. So the R value was really weak. So that's what we're talking about today again with our scatter plots, is the R value. And actually today we're going to use the R squared value because we're not using linear lines. So we need to use R squared. And R squared can be used for lines too, but it's going to be useful for all these different shapes. So in the R squared one, you don't need to learn this, but just for your information, R squared is called the coefficient of determination. And again, just like the R value that we talked about for linear lines, R squared needs to have its value closest to 1. And the one that is closest to 1 is the model that better fits the data. And you need to make sure your diagnostics on your calculator is turned on. And I'll talk about that with you in a minute to remind you how to do that. All right, so taking a look here. We got one question to do, and it's going to take us a long time because I'm going to go over all kinds of things with you on it. It says modeling data. The table shows the number of single beds, capital B, in thousands. Notice it says in thousands, on North American cruise ships from 2007 to 2012. It says use the regression feature on the calculator to find linear model, an exponential model, a logarithmic model, and identify the coefficient of determination for each model. Let T represent the year and T equal to 7 correspond to 2007. All right, so 2007 is going to be 7, and then 8, 9, 10. All right, and going back to the front page here, I forgot. I labeled on here, down here in yellow, which one those were on your calculator. So the logistic growth model is choice B, linear regression is 9, the exponential regression is 0, and the power regression is A. See, power, exponent, logarithm, they use natural log for doing the logs, and then logistic is spelled logistics. All right. So they want us to do 3 on it: linear, exponential, and logarithmic. You might want to go grab an extra piece of paper. It'll help. So why don't we just start with the linear model and put those numbers on our calculator. So let's turn it on. And remember, the first step to enter numbers in the calculator, you have to go to Stat, which is on the second row of your calculator. Let me move this over to the right. Well, I guess that's the left. Anyway, turn on your Stat. And under Stat, you hit Enter now. And if there's anything there, you go up to the top and you hit Clear to get it out. And you go down one and it goes away. So anyway, remember here, list 1 are the X values. So list 1 is going to be the years. And list 2 are the Y values. So X values, Y values. So we're going to enter all the X values in list 1 and all the Y values under list 2. So entering those on my calculator here. So we got 7, 8, 9, 10, 11, 12. And then going over here to the other side, we have, by the way, you should really play with me here. We got 260, 270.7, 284.8, 307.7, 321.2, and 333.7. Then I'm going to eyeball it, make sure I put all my numbers in correctly. Okay, I think they're all in there right. All right, so we're going to do the linear model first. So I'm going to go back to the word Stat, and then over to, oh, wait a minute, Stat. What am I hitting second for? So go to Stat. There we go, Stat. And we want to go over one menu to calculate. And we're going to go down to linear regression number 4. And then we're going to hit calculate. And it gives us the equation of the line. So the equation of the line here, so for letter A, they wanted to have a linear. So the linear model gave us y equals A, 15.51 times x, and then plus B, 148.99. And the r squared value is 0.9897. Well, let's take it out one more place. So 9. So 5 numbers out. So that's easy, and that's really all you needed to do. I'm going to overachieve here with you, though. Let's overachieve now, which is more than you needed to do, but it's kind of fun. All right, so what we can do is to see those points plotted on a scatter plot is we're going to go to Zoom and go down to Stat. Zoom, Stat, choice number 9. And when you choose choice number 9, it's going to plot those points for you. And, well, did we do that? Let me see, what's under Y? Oh, I have something. Oh, I had it in there already. I don't think I showed you how to do that. Let's go back to that. So, back to Stat, calculate linear regression, which was choice 4. So on choice 4, what you can do, you can store your equation down here under store equation. What you have to do is you go to the word var here on the third line, var, and then you go over to yvars, one menu, and it's the first one, function, and you want to choose number 1. Y1, and then when you hit calculate, it stores it automatically for you under Y equals. It's right there, it's already there, which is awesome. And so then you can see your points and then the line going through those scatter points. Kind of fun. Again, I wrote it down here what you need to do. So you need to, when you plot the points, choose Zoom Stat to automatically just have it make a good window for you on it. and it'll fit the scatter plot to that window. And we want to make sure we turn on the word plot, by the way, under y equals. So under y equals, make sure you have plot highlighted. Highlight it right there, and that way it plots your points for you. And then if you want to know what your window was, what your calculator did, if you go to window, you can see it graphed it then from 6.5. It counted by 1.57. All right. So every tick mark was 1.57, and it went to a max of down here of 12.5. And then for the y's, it went from 247 up to 346 when it plotted the dots there. And they look pretty much like they're linear, but I don't know. Let's try the next ones. So the next one they wanted us to do was the exponential model. I'm just going to, well, I'll write it down. So exponential. Okay, so again, we're going to go back to the stat. We got all our points in already. Go over to calculate, and exponential is choice 0, enter. And I'm going to store it again under y1. So again, I go to the word vars, go over 1 to y vars, hit enter on function, and then hit enter to get y1. So the equation is going to be automatically stored under y1 again, which is awesome. And see, you can see it graphed it already. So y equals, no, it didn't do it. Let's fix that. So stat, go down to exponential. Well, let's just clear out what's in y1. Maybe that'll help. So stat, calculate, go down to exponential, choice 0. And let's see, store it under y1, so function, vars, y, function, y1. All right, and now hit calculate. All right, so before I leave it, I want to write down the equation here. So y equals a 179.2 times b, which is 1.054 raised to the x. There we go. And the r squared value is 0.99474. Again, let's go back to, oh no, we want the r squared value. Son of a gun. The r squared is 0.9895. There we go. I'm sorry about that. All right, so let's look at the graph again. So that does the power function on it for you, and we can double check, make sure that's what's in there, and it is. It's the one we just wrote down here. It takes it to all kinds of decimal places, which in no way would you want to write all that down yourself, but it just automatically puts it all in there for you, which is kind of nice. Again, overachieving. We didn't need to do all that, but it's kind of fun. All right, the last one they wanted us to do was the logarithmic model. All right, so let's go back to stat. Calculate. The logarithmic model is number 9. Hit enter. Again, oh, you know what? Let me clear out y equals. Stop that. Second quit. Y equals. Get that one out of there. All right, back to stat. Calculate. We're going to go down to linear regression, number 9. And let's store it again for fun under y1. So let's see, we got to go to vars and y vars function and hit enter on that. And so now we got y1 there, and then calculate. All right, so the logarithmic one is y equals a, which is negative 24.199, and then plus b, which is 143.44. I don't care how many places you guys take it out. 2 places would be nice. I don't really care. And then b natural log x. So negative 24.199 plus b, 143.44 natural log of x. Okay, we need the r squared value again. And r squared for this one is 0.98069. So that one would round up technically. All right. So all we had to do on choice A was find the models, which is what we did in purple, and find the r squared values, and then figure out which one's the better model. Again, we overachieved by putting all of it in the scatter plot, but it was fun. You know it was. If we look at the graph of this one, you can see, the logarithmic one scales over that way. I don't know. They all looked pretty good, but let's see which one worked the best. Let's double check it's under y equals. It is. All right, so the one that worked the best is the closest to 1, and they're all super close to 1. Let's go out. If we go out 2 places, they're all the same number. If we go out 3 places, we have a 9, a 9, and a 0. So these two are definitely bigger, because that's 980, that's 989, and 989. So going out 4 places, 98, 97, 98, 95. That one wins. That's bigger. So the best model for it is the linear model, because the absolute value of r squared, well, just because r squared is closest to 1. We don't need to say the absolute value on it. Of course, it's positive because it's squared. It says on C, use your model you chose in part B to predict the number of beds in 2017. So in 2017, be careful, we didn't use the whole entire year when we made the model. We used just the last number. So in 2017, T is going to be equal to 17, not 2017. You want to plug in 17. And we chose the linear model, which was y equals 15.51 times x. And again, I'm just going to put the 17 in. Plus 148.99. So we're plugging the 17 in here for the value of x up here. Let me pull that back down. We're plugging the 17 into the linear model right here for x. So 15.51 times 17, and then plus 148.99, and we got 412.66. Or I'm going to round down because we can't round up to a bed. So we have 412 beds in 2017. And wait a minute, all right, I don't know if someone caught it here already before I said it, but the original thing said everything's in the thousands. So technically we have 412,000 beds in 2017. Yeah, we'll leave it like that. All right. Well, I'll see you guys tomorrow.